So let's move on to control statements. So these, as I say, are statements in Python code or in other languages that affect the flow through the program, or the way you move through the program. In our program for free fall and our program for the satellite orbits, we just went sequentially through the lines of the code. So we executed line 1, executed line 2, executed line 3 to the last line of the code. In general, more generally in a computer program, you just don't go sequentially. You make various decisions. So you might decide, I tried to list some of them here. So you might decide you're going to execute certain lines and not execute other lines. You might choose between this line or that line. Or you might repeat a line or group of lines multiple times. So this is the flow through the program. This is determined by the control statements in the program. And so that's what these control or flow statements do. They govern the execution of the other statements in the program. So the examples that we'll look at from Python are the if statement. So the if statement is going to determine whether some following code is executed or not executed, and determines whether the following code is executed or not executed based on a condition in the if statement, whether that condition is true or whether that condition is false. A while statement, okay, that will determine, that will loop over some code. It will keep running through code as long, in that case, as long as some condition associated with the while statement is true. So as long as that statement, that condition in the while statement is true, it keeps looping through the following, re-executing and re-executing the following code. The for statement, I'm going to say a little bit about this, but we'll say more about it next week. This is a statement that also causes repeated execution of a line of code or a block of code, but it's a repeated execution of a line or lines of code based on, for each of the elements of a list of items or an array of items or over a range of numbers. And so that's another way in which you can loop over executing many times. And then finally, I'll say a little bit about break statement, which is a way of kicking yourself out of, say, this loop here, the while statement, or kicking yourself out of this for loop here, which is meant, again, a loop or many executions of the same code. So that's sort of the overview of what we'll do. Okay, so now I wanted to get out of this. And just work through a couple of examples. I think I got 3 examples here, and then I'll just I'll show you the assignment, and if you've got questions about assignment, we can talk about that. Okay, so I'm going to show an example code for the if statement. So we get a little look at that in Python. Example code for the while statement in Python. We'll get a little look at that. And I'll show another one for the for statement. As I say, for the for statement, because often we use it to loop through the elements of what we call a list or what we call an array. And we haven't yet met lists and arrays in Python. I'll be saying more about the for statement next week. Anyway, so this one is to just demonstrate use of the if statement. This is a rather contrived example I've got here. So I'm going to introduce a variable T for the temperature of some H2O. And I'm just going to assign a temperature of 120 degrees Celsius for my H2O. Okay, and then we're going to write a code that's going to tell us whether the H2O is either ice, or it's water, or it's steam, based on if statements, the family of if statements. You know, just writing out whether it's water or steam or ice doesn't sound very useful, but you could imagine in a real physics code, right? That might be a simulation of some materials that you might want to know based on the temperature, whether that material is gas, liquid, or solid. So this could be useful in a real physics code that we'll do later on. But right now it's just an example of if statements. So, and specifically, it's going to introduce us to there's kind of a family of if statements. So there's the if statement, there's the else if, and then there's the else statement. So we'll see these three statements. So let me write this out because I can't talk and type at the same time, apparently. So here's the format of the if statement. So here's the control statement, the if, and then it's followed by a condition here. And if that condition is true, then it's going to execute the following code here. So this condition here, I said, if t is greater than 100. And after the condition, one thing you do is you follow it with a colon. So control statements like if statements, we'll see it also for while statements, for statements, are followed by a colon. And then the code that's going to be executed here by the if statement, it could be a while or a for statement, that's indented. And so here's the indentation. There's white space here. And so this is the format of the if statement. And so the idea is here, if this condition is met, if the temperature is greater than 100 degrees Celsius, we're going to print out the fact that this H2O is steam. So that miraculously did work. Okay. I said there was a family of if states. So there's also else if and else. So maybe the temperature is room temperature. What's that, 21? And that will give us an opportunity to use the else if. Else if is written in Python just ELIF, so else if. So that's the, again, a control statement. This control statement has to follow a if statement. So it has to have a preceding if statement. And it's a condition that's going to be applied if the previous if statement was false. So if the previous if statement is true, we're not going to do this else if, test this. But if this previous if statement was false, then we are going to test this other condition. So the second condition I'm going to put in is if we're greater than 0, if the temperature is greater than 0, so that's another condition. Again, I've got to end this with a colon. So it's, again, it's a control statement, it's a condition terminated with a colon. The code that we're going to execute is indented with white space here. And if it's greater than 0, then it's going to be water, liquid. And so this is my else if. And for this temperature 21 degrees, then it's, let's see how the code flowed. The code first tested to see whether it was greater than 100 degrees Celsius. And it wasn't. So we didn't execute print steam. Because it failed that if statement, the condition was not true in the if statement, it tried this else if, and that was true. It was greater than, the temperature was greater than 0 degrees Celsius. We printed water. So if I will go back and put in 100 degrees Celsius, then, oh, I don't want to, it's not a good choice. So it prints steam because here the first condition was true, so it didn't try the else if. Okay, so this else if is only, that condition is only tried if the if has failed. Maybe temperature is minus 10 degrees Celsius. We're going to have else, ice. So that'll give us a chance to use the other member of this family of sort of if statements is the else. Now the else statement is you can only have one else statement. You can have multiple else ifs. You have one if statement. You only have one else statement, and it has no condition. So it's just going to be executed if the if statement and all the else if statements are false. So if all the other ones are false, this will be executed. Again, it's a control statement, so we're going to end that line with a colon because it's a control statement. And if both of the other conditions are false, then this must be ice. And so let's execute that and we get ice. So that's an example of using the if family of statements. We've got if, we've got else if, we've got else. As I say, you're going to use if once. You can only use else once associated with that if statement, or you can not use it at all. You can use else if multiple times. You could have multiple else ifs. So that's kind of the format of that. The condition that I had, I was always testing whether the temperature is greater than 100, or temperature is greater than 0. But there's lots of conditions. So you can, to test if say T was equal to something, you can do that. You would use 2 equal signs. If you want to test greater than or equal to, then that would be a greater than and an equal sign. So those 2 symbols. You can test if something is not equal to, that's an exclamation mark and an equal sign. So all those are, I listed them in the class notes, but there's a number of conditions you can test. You can also combine conditions. So you could have 2 conditions and you could say if condition 1 or condition 2 is true, then you'll execute the statement. Or you could say if condition 1 and condition 2 is true, you can execute the statement. So you can make quite complicated conditions to determine whether you'll execute or not execute the code. Is that fine for the if statement family? Just a little family. Okay. While, we wanted to do while statement. Okay, so for the while statement, so now I'm going to start moving on things relevant for the prime numbers. Finding factors. So prime numbers, the only factors are, 1 in themselves. Composite numbers have, other factors. And then, so I'm going to use that as finding factors as an example for the while statement. And then when I come to the for statement, we'll use the finding primes as an example for the for statements. Okay, so I'm just going to work in this new cell here. So I'm going to define a number that we're interested in, so 1,000. And am I in a text box? I think I am. And we're going to find the factors of this number 1,000. So I've defined a variable and I've assigned it to 1,000. So the format of the while statement is, again, you write out the control statement. So here's the control statement. Then again, there's a condition. I'm missing out a line. I want to put, sorry. Let me define another variable here. So I'm going to call this factor, this variable factor. And this variable, we're going to increment through the values of this variable factor. We're going to increment from 1 to n, to the number 1,000. And I'm going to initialize it as 1, start it with 1, and you'll see that I'm just going to increment it one by one till I get to 1,000. And we're going to test whether it does divide with no remainder the number n. So what I'm with the while statement is the control statement. Then it's followed again by a condition. So the condition that I'm going to use is that factor is less than or equal to n. So this again is a control statement followed by a condition that the factor is less than or equal to n. It's obviously less than, it's 1, and 1 ends 1,000 at this point. And again, the while statement, just like the if statement, is terminated in a colon here. And then the code that's going to be executed, and I'm going to have several lines of code here rather than just one line of code. So it's a block of code that's going to be executed. That code is indented, just like the if statement. The first thing I'm going to do is divide. I'm going to use an if statement, so another control statement, and I'm going to see if I divide n by factor, whether there's any remainder. So that's this statement here. So here's the control statement. And here's n, the quantity, the energy that we want to know what the factors are. Here's the factor. We're trying to see if it exactly divides n by. And this operation here will give us the remainder when we divide the integer n by the integer factor. And so if the remainder is 0, then it does divide, factor does divide n. And so this is the condition that's testing whether the integer factor is a factor of the integer n. If it is, we're going to print that number. So let's just print out factor. And so this should give us a list of all the factors of the integer n, of the integer 1,000. So this indentation is indented from the if. So this is the code that's going to be executed by when the condition in the if statement is true. It's just executed once. And then after that's executed, it's going to return back to that block of code that's executed in the while statement. And all we're going to do there is increment factor by 1. So the first time through the while statement, factor is 1. So we're going to see if we can divide by 1. Then we're going to increment factor and we're going to try and divide by 2. And then again increment factor and divide by 3, and so on and so forth. And so this is our little code that now involves, we've introduced the while statement, and it's going to allow us to find the factors. And so I just ran that. And so here we see all the print statements, and it's printing out every time that we can exactly divide n, which is 1,000, by divide n by these different values of the factor. And so obviously we can divide it by 1,000. Obviously we can divide it by 500, by 100, by 2, by 5, by 10, and so on and so forth. Is that okay, that example? What else did I want to say about that? Okay, so this one, a couple of things. So here you see I've been using different types of conditions. In the first example, I only had condition that that the temperature was greater than 100 or greater than 0. But here, this is less than or equal. This is equal to. Here, we didn't use this in the previous class. We talked about the sort of native operations that are in Python. So there was multiplication, division, addition, subtraction. This is another native operation where you find the remainder from division. This is a shorthand way, I don't think we did this in the last class, of adding 1 to factor. So we could say factor equals factor plus 1. So that's redefining factor as incremented by 1. And this is a more compact way of saying that. Just to show you one thing you can do in Python that's sometimes useful, you can time your code. So if you put, this is, it's kind of like a little macro, little operation you do asking the to be done when you run the code. Here's and they begin with this percentage sign here, and this will give us the time that it takes to run this piece of code. Now, it ran immediately, as far as we can tell. It just took microseconds. But if we were to, and this is the thing about encryption, right? If we would try and find the factors of a much larger number, so this is 1 billion. So let's try and find the factors of 1 billion. And the problem here is that it's going to take a long time, because it's going to have to walk through from 1 to 1 billion, trying all of these. And so this is why kind of encryption works, that it just takes, it's not that it's impossible to write a code to find the factors of some very large integer, which would allow you to break the encryption. It's just that it will take you infinitely long to do that. And so you see here that it's going on and on forever. I think it should stop soon, but if not, I'll just break in. So this is the problem, even for 1 billion, right? It takes a long time to find the factors. Obviously, my way of finding the factors is not really optimized, but okay. So that's if statements and while statements. I guess I'll stop this. Let's do the for statement. So I'll just start another cell down here. And I think here what I want to do is just write a little bit of code to figure out whether a number is prime or not prime. So I'm going to introduce another n and assign it to a value, and we're just going to figure out whether this number is a prime number or a composite number. And we'll just use this as an example of the for statement, and I'm also going to use that one last control statement I mentioned, the break statement. So again, maybe I'll write in this little bit of code and then discuss it. Okay, so here's the for control statement. Again, it goes at the beginning of the line here. And the format, though, of the for control statement is a bit different. So in the if statement and the while statement, the if or the while was followed by a condition that we're going to test whether it's true or false. In the for statement, basically what the for statement does is that it will execute the following code for, say, all the items in a list. And I'll say next week a bit more what Python list is, or all the items in an array. And I'll say next week a little bit more about what the items in an array are. In this case, it's going to walk through the code with this variable I set to values that are in this range from 2 to n. So this is a particular way of using the for statement where we're just going to execute the subsequent code for each value of I in this range running from 2 to n. Actually, it runs to, the limit is actually, the last integer that it will run is n minus 1. And so the point there is that if n is prime, if 997 is prime, then it's only divisible by 1 in 997. This range here goes from 2 to 996. So it goes from this number here to 1 less than the second argument here. And if we find that the number n is divisible by I, then that means it's going to be a composite number. So one way I could write the code is just to, kind of similar to the last example, I just see if I divide n by I, whether it's 0. And if it's 0, then I can just print the fact that I found that this is, I is a factor. This is a composite number. So this line here is really the same line as I used in the previous example where I was finding the factors. I would be a factor of n if when I divide n by I, there's no remainder. So if n is divisible by I with no remainder, I found that this is a composite number. It's not a prime number. And so, this is one little bit of code I could figure out if n was, well, let me make this 1,000. If n was a prime or not. If it's not a prime, then I'm going to be printing out composite. And of course, I printed out many times. We found all the things that 1,000 was divisible by here, the factors. And so for each one of those, I'm printing out composite. And so that's a little bit ugly, right? To find I'm going to find a prime number by, that I get one or more printouts of composite. So a little bit better way of writing this in terms of the output, and also a faster way for a large number, if n is a large number, would be to not go through this entire range. Once I find that it's a composite, I could break. This is an example of the break statement. Break out of, let's see, I want to break out of, no, sorry. I'm going to break out of the for statement. So as I mentioned, when you have a while loop or you have a for loop, it will execute the while loop or the for loop if the condition in the while loop is true, or if we're walking through this range in the for loop. But you can break out of those loops with a break statement inside that code that's being executed. So this will break out of that loop. If you break out of a while loop or a for loop, you can, if you break out of it, then let me say, if you don't break out of it, if you don't break out of the for loop, then you can execute, you can put an else statement. So this will be executed when you didn't break out of the for statement. And so if we didn't break out of the for statement, that means it wasn't a composite, so it was a prime. And so we would execute this line here. So let's rerun the code with this little addition here. We've added the break statement, which stops us executing and printing out many composites. And we added this else statement so that we can print out prime if it wasn't a composite. So if it's, if we run it with 1,000, it will tell us that it is a composite, and it just tells us once. And if we run it with 997, that is a prime. And it tells us it's a prime. So this little code here will tell us whether the number is, so this is using a for statement, an if statement, and a break statement. And so this tells us whether we got a prime number or a composite number. Again, here you can see, like, I looked this up, I don't know the primes. Okay, so this is a prime number, if I remembered it right. And you'll see that the problem with this code, again, it's challenging to find factors or search for factors of large numbers. So it'll take a while to figure out whether that is a prime number or a composite number, because it's having to do multiple tests to find if it's a prime number. There were ways to make this a lot faster. And if you're interested, I put one more example. I'm not going to go through it here. One more example code, sample code in our modules directory for this module. There is a fast algorithm for finding primes. There's a number of tricks you can do. Obviously you don't have to go through and try and divide by everything from 2 to the number -1. You only actually have to go through until you reach the square root of that number. Because if there's not a divisor down there, you won't find a divisor above there. And so that can save you a lot of time. There's other tricks for saving you a lot of time. And so that there's a final sort of fast algorithm code where you'll see more examples of control statements. Okay, so that was all about introducing the control statements, because in most code, right, you just don't go from line 1 to line 2, line 3 like we did in the first class examples. You really have a flow through the program that depends on conditions, testing conditions, and often involves executing the same code multiple times in loops.